Okay, here we go. Son is having his cake now, and we're going to have a video now. So this is 15.5, and we're going to talk about a triple integral. So what we need to do is just show you how to do one, in case you get stuck having to do one. And who knows, you might. And so we're going to work on that part first. So that's like having a 1 there. So that's where that z comes from. Then you have to plug in your boundaries by your fundamental theorem of calculus, here and here. And you end up with that expression, basically 2x plus y minus 0, or just 2x plus y. Then you integrate with respect to x. When you integrate there, you end up with x squared plus xy. And so again, you need to substitute by your fundamental theorem of calculus the boundaries that you see right here. So when you plug that into the first number into that, you end up with the 4 minus y squared, and then you plug this one into that. Then you have minus this, and these things subtract out. And now you just have to work with what's left, and the double negatives turns this into a positive, and that's why you have 2 of these. So assuming you don't like all my little underlines and things. And if I move that up, then you're left with having to do this integral, which requires substitution. So you integrate by substitution, you end up eventually with a negative 2/3 u to the 3/2. You resubstitute your substitution in, so you have a negative 2/3 4 minus y squared to the 3/2. You plug your 2 into that, and it's going to give you a 0. You plug your 0 into that, it's going to give you a 4. And so when you clean all that up, you end up with 8 times double negatives turns that into a positive 2/3. So it's 8 times 2/3, and your answer is 16/3. What does this mean? It is a volume. And what you're doing now is you're summing up an infinite number of little cubes, not rectangular prisms like you were doing with a double integral. You're summing up an infinite number of cubes. And you say, what do you mean by cubes? Well, guess what the change in x and the change in y, or excuse me, the change in z, change in x, and change in y is? That's going to form a little small cube that you're going to eventually sum up an infinite number of these by going through that process right here. So that's how you do it. Now we have to talk about how you translate them. And so that's what this picture is from a book, the book I first taught out of, Swakowski. And basically you can see a surface. You have a surface here that is, if you can see it that well, but this is z and it's k sub 2, and this is a z and it's k sub 1. So you have your boundary there, and you then have your boundary that you see that's highlighted down here on your two-dimensional shape. Well, remember the story I told you, you don't need to draw three-dimensionally to figure these out. It can be done without having to do all of that. So let me try to talk you through the process. Okay. So when you're looking at your setup, if this is your volume that you have, and let's get a lighter color. If this is the volume that you have a variety of boundaries. This is the surface K2 up there, and this is the other surface K1 that you see here. K1, K2, or Z sub 2 and Z sub 1 if you really wanted to think of it that way. But you have equations associated with those surfaces. That's going to be your inner boundary that's with the surface. And so that's your boundary that you have from here to here. Now to figure out the last part of the boundary, let's get a different color, then we just simply have to look at the projection of that shape, whatever that boundary shape is, onto the XY plane. And then we can draw this the same way we've always drawn it, and that's going to be a vertical representative rectangle type of situation. And so the upper boundary, which might be something like this, is going to have this portion as a boundary, and the lower boundary is going to have this portion as a boundary, and we just have to set that up by, guess what we're going to use? Our favorite thing, a representative rectangle right there. And so just like we talked about with the 2 dimensions, this is going to be your dx, okay? So your dx is going to be the thickness, and how far this thing has to slide is going to be your dy. Alright, so let me start over again with this. I think I just said that backwards. Yeah, I did. Okay, so this is the thickness, and this is your high, and this is your low, and so that's what you're going to have here is the high and the low, just like we did with the double integrals. And how far it slides is going to be from A to B, and that's going to be your boundaries that you have. But how far it slides is going to be based upon the x's, and it's going to be based upon the fact that this is still, when we set it up, this is your thickness, and this is your high, and this is your low. So we just have to figure out what are our boundaries going to be when we're talking about these different shapes. So we can have a 3-dimensional shape drawn for us, and that'll help, but we don't always have to have it if it's described well enough. Alright, so let me show you what I'm talking about with the next slide. Okay, again, this is out of the Zukowski book. Here's another picture that is kind of showing you the same thing as the other one, actually. And again, here's another picture that might help you visualize what's happening. Okay, so the upper boundary is going to be this equation, and the lower boundary is going to be the xy plane, and by the way, the equation for the xy plane is going to be y, or z, equals 0. We should know that from our discussion back in chapter 12 when we talked about it. If you're missing 2 variables, then the z has to be equal to 0, and the x and the y can be anything, which means it's the entire xy plane. Now, the cutout shape for whatever this shape is going to be indicative or indicated by this intersection with the xy plane. Or it could just be restricted based upon the boundaries that you see, based upon that equation. So if you were to project that down and draw that 2-dimensionally, guess what we have? We have a vertical representative rectangle, and you have high minus low, and this is going to slide from 0 to a 1. And so if we were going to set this up, see if anybody wrote it anywhere, well, I'm going to write it over here on the left-hand side in black. This triple integral would be, for my upper boundary, I would have the 2 plus x squared plus 1/2 y squared. I think of those are the numbers. They're kind of, let me zoom in. Alright, I can't read it. Oh, it's a 1/4. Okay, that's easy to fix. This is a 1/4 y squared. I guess I should just look at this. And my lower boundary is going to be the xy plane, so that's going to be 0. And so I have my first boundary is the 3-dimensional height and the 3-dimensional bottom there. So your high minus low as far as 3 dimensions. Now, if you want to set this up, and there'll be times we're going to change the order of integration, but we've set it up with a vertical representative rectangle. So I'm going to have for my high, it's going to be the square root of 1 minus x squared, and I'll have a 0 for my low, and this is going to slide from 0 to 1. But because this is the thickness, my outer boundary is dx, and my middle boundary is dy. So I'll tell you right now, a lot of times we're going to set these up as dz as our first and then some form of dy dx. And very rarely do I change it, but there are times I have to change it. So let me go back so you can see the whole picture, and hopefully that will be sufficient for you to look at that before I go on. All right. Oh, here it is, same thing. We just talked about it. Here's the setup, and it's the same thing that we just discussed. And so let's see about highlighting certain little things. The dx is the thickness of this right here. This is going to be the high minus the low of that representative rectangle, and that's going to be the dy. And then finally the dz is going to be this upper region, and then the lower region, which very many times it's going to be the xy plane, so a lot of times it's going to be a 0. Will it always be that? Oh heck no, but most of the time it's going to be some variation of that. And so that's going to be your inner boundary, the dz. Okay, so this is parallel to the z-axis three-dimensionally, the boundaries that you see in yellow. The boundaries you see in orange are going to be parallel to the y-axis, upper or high minus low, and this is going to be the slide along the x-axis. And you translate that based upon the setup that we choose to use. Alright, so looks like we changed the order of integration here, but we kept the dz the same. But we did a horizontal representative rectangle. That makes this dy, and this makes this right minus left. So the right has to be solved for x in terms of y, and so when you do that to that piece of the circle, it's going to be the square root of 1 minus y squared. And the left is going to be a 0 because it's the x equals 0 y-axis. And this has to slide from 0 to 1. And so you can change the order of integration, and you can set it up as long as you don't have a change in boundaries, and you avoid that like the plague. So again, this bottom one, I'll wait a few seconds, and you can copy anything that you want to copy as far as the two different setups. Alright, moving on. So we're going to talk about setting this shape up that you see right here. And so the equations are given. Let's read this. Okay, we're supposed to set up the triple integral, iterated triple integral, that will find the volume V of the solid that's bounded by the cylinder y equals x squared, and the planes y plus z equals 4 and z equals 0. Well, you know what that is. That's the xy plane. That's down at the bottom. So the other plane, the surface that you have, is this. And so if we decide to do dz first, which is what we're going to do, then we would have to solve for z, and we would have 4 minus y, and that's what the boundary is going to be right here, and it's going to go down to a 0. That's the three-dimensional part of that representative rectangular solid, if you want to call it that. But then I leave that picture and I go ahead and draw and talk about a vertical representative rectangle. Alright, so now I'll have high minus low. And so the high is going to be a plain old 4 and the low is going to be an x squared. Now, how far would this thing have to slide to get all of that? Well, it's going to have to go from negative 2 to 2. And again, because this is my thickness, that's the outer one, and this is my inner middle one right there. So we go from the 3D to the two-dimensional projection onto the xy plane, or whatever the surface is. Whatever the heck the surface may be. What would it look like if you shine from, like a flashlight from above, that shape? Okay, count to 3. If you didn't pause it, it's too late now. Alright, here's another picture. If you don't like that one, it's pretty much talking about the same thing. So this was an example that came out of the old Swakowski book. They had a lot more pictures in the Swakowski book, but there's a few in your Thomas book. Alright, so the setup we just did on the previous page, talking about this one right here. It's the same idea. Alright, let's move on. Alright, this one we're going to have so much fun because we're going to do it all sorts of different ways. It's given to us one way and we have to translate it, and we're supposed to do it the other 5 ways so that you can see all that goes into it. So let's do what we've talked about. Let's translate this in the format that it's currently in, and it's the typical dz, dy, dx that you're so used to. Okay, so when we do that, the surface at the top is going to be this z equals y squared. That's why you have a y squared here. The surface at the bottom is the xy plane, which is z equals 0. That's what this is going to be. Now, if you project that parallel to the z-axis, it's this way, it's going to form this rectangular shape, or maybe a square shape, that you're going to see drawn. And how is it going to be drawn? Well, it's in the positive x-axis direction, because this is a positive 1 right here. But it's going in the negative y-axis direction. That's a negative 1. So that box that you see, and I'm going to erase all this in just a second, it's going to be that box right there in quadrant 4. So the way this one's set up is you're drawing a vertical representative rectangle. And so you have your dx right there, and the boundaries are going to be 0 down to a negative 1, and that's your dy for that, the high minus low, and this has got to slide from 0 to 1. So there's your setup, and I think I need to erase a bunch of these little symbols right here so that you can see it. Okay, so let's erase this so that I can do other examples. So let's do the easiest one first, which would be E, this one. Because honestly, we're doing the same exact thing, except we're changing what we just did to be a horizontal representative rectangle. That's all we're doing. So if I set that one up, and I know my wife has done it somewhere down at the bottom, but I'm just going to write it right here. We're going to have the same equation, 0 and y squared, for this part right here, dz. And then we're going to have some fun when we start projecting different ways. But we're changing this to dx, dy. So if I'm doing this horizontal representative rectangle, I have to do right minus left. So that's a 0 and a 1. And we have to get the region that it's going to scan, and that's going to be from a negative 1 to a 0. And then some of you are just going to say you just swap those values, and because it's a square or a rectangle, yeah, I did. Is it always going to be that easy? Oh, heck no. No way. Okay, so again, let's see. Well, my wife doesn't show it on this one, but when I show it over here, here's the one that I just did for you. So I will pause eventually on that side as well. But I'm going to erase that. It's on the other side for E, because you can jot that down, look at it, whatever you want. And I'm done with that particular picture. And so what I want to do now, if I go in the order that we have it, and we do dy, dz, dx, that's the order that we want to do it this time. So I have to shine my light parallel to the y-axis. Okay? When I shine that light parallel to the y-axis, if I could somehow draw in here, we would be at the back, which is the equation y equals a negative 1. That's the back of that thing, to this side of the parabolic shape that you see, the slide, and that's going to be what? Well, if you solve that, y is equal to plus or minus the square root of z. Alright, that z is hard to read, so I'm going to try it again. So that z, alright, I can't make a better z because I'm writing too small. That's the best z you're going to get out of me. So if it's on the negative side of the y-axis, then we want the negative side of this. We want a negative square root of z. If it was on this side over here, we would take the positive version of that. So what we would have as our boundaries for the first part of this, for the dy, when we set that up, it's going to go from the back to the front of that shape. So the back is the -1, the front is going to be that negative square root of z that I just talked about. Now if you shine that light, what you're going to see on the xz plane, that xz plane is going to just be another rectangle. Oh heck, I'm not going to spell rectangle. You can see it right here. It's a different color. There's the rectangle. Alright, since we're doing dx dz, that means the dx is the thickness for that thing. So we're looking at that. And so I have to do high minus low. So I'm going to have from 0 to 1 for high minus low, and it's going to have to slide from 0 to 1. Now, here's the thing. If you do this one, is there really much to change? No, it's going to be the same beginning part. And then this rectangle, when you change it to be a horizontal representative rectangle, it's still going to have right, left. It's going to be a 1 for the right and a 0 for the left, and it has to slide from 0 to 1, so it's the same setup, and again it's because of that square. Alright, so there's A and B, and we've already talked about E. So now we have to talk about C and D. I don't know if the picture's on the other side. Let me check. No, the picture's not on the other side, so I'm going to have to scribble around here, and as I scribble, I'm going to set it up and write it where I have the picture. Okay, so if we're going to do in the order that you see for C and D, let's do light blue. If I do the dx, okay, then I have to shine my flashlight this way, parallel to the x-axis. And if I shine that, the first thing it's going to hit is this side, and the last thing it's going to hit is this side, which is the YZ plane. Okay, that side is the YZ plane. And you can't see that very well, so I guess I better get a darker color. The YZ plane is x equals 0. Alright, so I'm going to write this out in the order we'll do C first. We have our triple integral. We're doing it dx, dy, dz. That's the order that we're going to do it. So as I was mentioning with that flashlight, it's hitting that one first, which is a 1. And the one that's back to the other plane is going to be x equals 0. So that's your boundary. Now, when you do the two-dimensional shape, the two-dimensional shape is going to be, and we're talking about now, the YZ plane. See how we're changing that? So the YZ plane is going to hit this point that's going to be at -1, 1, and then it's going to have this parabola. I need to try to draw that parabola again. Okay, and that parabola's equation is, I think I'll write it somewhere else. Z is equal to y squared. Okay, so we're supposed to do dy dz. So the one I've chosen here, unfortunately, is the one that's going to take more work. But we're going to have to do a horizontal representative rectangle because my dz is my thickness. And I have to do right minus left. Well, when I do right minus left, I have to have this equation solve for z, or excuse me, solve for y in terms of z. And we've talked about this already. This is plus or minus the square root of z We talked about it, and we want the left-hand side, so we want the negative. So that means the right is going to be the negative square root of z, and the left is going to be the negative 1. Z equals a negative 1. And this will have to slide from here to here, so we're going to have a boundary that's going to be 0 to 1. So that's how you do C. And again, it's on the next page. I will go ahead and pause later, but I'll pause right now since the explanation is here. I'm going to take a sip. Okay, so if you didn't pause me and write down what you want, it's too late, baby. It's too late. So I'm going to erase all that, and we're going to do it again. Well, I'm not going to erase everything. I'm going to erase a lot of it. So I want to change this to a different order. I want to do D, but I need to draw a new representative rectangle. So I guess I'm going to try to do that and see if I can draw my shape back in. Oh, don't go away. So here's my shape back in, and I really should have erased the R and the L. That was a pretty good job. And so if we're going to do the order that you see for D, which is dx, dz, and dy. Alright, because it's dy, and the way we have our y is like on the horizontal axis, we're doing a horizontal representative rectangle. So again, we've already talked about it as far as the boundaries from here to here, and that was a 0 to a 1 if you recall. Now, the boundaries that we're dealing with here in this case is this equation, which is z is equal to y squared, and we need to have that solved for that, so the upper boundary is y squared and the lower boundary is 0. And then this has got to slide from negative 1 to 1. Done. Finished. So, there's your example of doing it 5 different ways from the original drawing and the original setup that you're used to doing. And why would you do it so many different ways? So that you can get used to the different perspectives. Okay, probably of all the exercises that I've done, probably 8 times out of 10, I always do DZ first. But there's one occasion that's coming, I think it's number 12 in your book, that we have to do something different. We have to not start with DZ. And that's why it's imperative that you look at all the different perspectives. If you'd see me now, I'd be waving my hand over the iPad. All of them. Alright, so pause this if you want to copy anything. And if you want a neater version than all the things that I've written, then go to the next page after you've paused it. Here's the next page. Let me make it so you can see it. And there's the same things that I've written in all my other beautiful colors, again with my wife's explanation and the pictures that we talked about before. Alright, so I'm going to count to 5. Alright, that's good. Let's move on. Here are 2 more examples, and let's just zoom in on one at a time here. And it looks like this is from our book, I'm pretty sure, if I remember this. And since it's nicely written out for us, I'm just going to highlight. So the first thing I have to do is realize, and I'm going to do DZ most of the time like I was talking about. The upper part it's touching is here. The bottom part is down here. Okay, so I could almost draw this. I'm going to try this. I've never done this with the colors because I destroy it and I can't use it anymore. If I do a different shade of yellow, maybe you can see the other one. Here's the 2 parts that I'm trying to get you to see. Alright, so if you take that equation, which is, oh my gosh, oh, it's a trig equation. Goodness, I'm just asking you to set it up. Don't have to have a heart attack about taking the integral. So the high one is the equation that you see right there, and the low one is this plane, which is the xy plane, and that's z equals 0. So that's why your boundaries are from 0 to that z equals equation right there. I need to get rid of all those beautiful pictures and things, so let's see, I'm going to just do this. And get rid of all the colors and things that I've manipulated here. Alright, so if you can imagine a flashlight shining down, then the boundary that you have is this boundary, and if you draw that, you're going to end up with the shape that you see over here. Okay, in that equation, where did I get the equation? Oh yeah, it's from here. That's what it's going to intersect. So it's in the first octant, bounded by the coordinate plane, and the plane also that's y equals 1 minus x. Why is that a plane? Because it's missing the z, it's going to be a plane. And it's going to be lying on this surface right around here. I don't think that helped anything. So I'm going to erase a bunch of stuff in this stray line that I somehow put on there by my hand, I think. There you go, go away. So I have a vertical representative rectangle. I've already decided about the dz. We're done with that. We're now doing two-dimensional. And if you don't remember high minus low, that's going to be the 1 minus x and then a 0. And you say, why am I doing that? Because I can't have the letters here match with the letters here. So I've got to have it solve for y, or solve for x in terms, no, solve for y in terms of x if I say it right. And this thing's going to slide from 0 to 1, and now you've officially set it up. Okay, so I'm going to erase this, let you copy or jot down anything that you want. This would be like me standing at the board and you all taking pictures at the board, and you never take pictures of me. It's very sad. Alright. Now we have set up this iterated integral for the volume of the region, and the region is in the first octant. Boy, that seems to be a common theme. And when it's in the first octant, guess what that plane is at the boundary at the bottom? It's the z equals 0 plane, which is the xy plane a lot of times. Now, here's your shape. Whoops. Here's your shape, unless you can see my eraser going across, which I don't think you can. Well, maybe you can. There's the shape, and that's going to be the top portion. So that's why we have this, and then we have 0 down at the bottom. If you take that, you're going to end up with the projection onto this to be that half of a parabola, I think it's what it's going to be. And so when you take that equation of the parabola, which is this one right here, it's when z is equal to 0, so that's why you can just all of a sudden put 0 right here. And then you solve that. Well, easiest thing to do is solve it for y. And again, some of you that can't graph, and there are too many of you out there, we're talking about this piece right here because it's in the first octant, which is the first quadrant when we start talking about two dimensions. Okay, so the intersection point at the x-axis is 2, and the point up here is 4, and if you don't know why that's a 2 down there, then just let y be equal to 0, and you solve that. And you get x squared is equal to 4, x is equal to plus or minus 2. We don't care about the minus 2, we care about the plus 2. That's where that 2 comes from. So pause me if you need it, but I don't know that you need it because we're going to do high minus low, which is the parabola, and then 0. And this has to slide from 0 to 2. And could I set that up where I do dx dy? Heck yes. Easy. Easy peasy. I would just draw a horizontal representative rectangle, and I'll show you how easy it is. We're going to have that same 4 minus x squared, or yeah, well, minus y, 0. We're going to have still the dz. We're going to flip-flop the dx and the dy. And so let's see, the right is going to be the parabola, which I have to solve for x in terms of y. So let's see, if I solve this for x in terms of y, I'll have x squared is equal to 4 minus y, and so x is equal to plus or minus that, and I want the positive version, so I'm going to have the square root of 4 minus y, and my left is going to be a 0, and that's going to have to slide from 0 to 4. So you could set it up that way if you wanted to. Alright, that 4 minus y is hard to read, so I'm going to try a different color just to highlight it. This is a 4 minus a y right there, square root. Now, didn't have to do that, but I thought, what the heck, it's not hard for us to flip-flop the dy dx and the dx dy, especially once we already have the picture for the other one of the versions. Now, could I theoretically take another 20 minutes and do a one that's going to start with a dx and one that starts with a dy? Yeah, I could do that, and it's easily done for this, but I'm not going to because I don't really want to take the time, and it's getting late. Alright, so count to 3. If you want to pause it, better pause it. Alright, let's move on, and I think this is the grand finale. Yes, definitely the grand finale, the big salami here. Alright, when I teach this in class, I've actually had students make these shapes for me. One did it as a trig student that just built it for me using some kind of paper and stuff and cutting it and gluing it together. And another guy did a 3D printer and printed this out. But here's the problem that you face, okay? If you were to take and try to do DZ first, this is your flashlight. When you shine, then you're going to have a boundary that's going to be hitting, I need different colors here, you're going to have a boundary that's going to hit this side, and then you're going to have a part of this that's going to hit the other side, and so you're going to have a change in boundaries. I'm talking about when it's shined down in the bottom. And so, heaven forbid, do you want to do 2 triple integrals? You're out of your mind if you want to do that. I don't want to do that. So, we have to do something else. We have to do either a dx first or a dy first. I really honestly don't care which one we do. So I need to erase this because I don't want that anymore. And I'm going to have to take and shine my flashlight another way. And, I guess we'll do it the way she did it, and we'll go the other way. Looks like we did a dx. So we have our flashlight shining this way, and so the boundary that I want you to see that's going to be shining back eventually, when we graph that 2-dimensionally, it's going to be that triangle that you see. Okay, and we're going to have to talk about how you get that triangle, and we will. It's going to come from this equation. Okay, now, as far as the surfaces are concerned, then let's get a different color. When I shine from this direction, it's going to touch this surface, which is this equation, and it's going to go back to the YZ plane. All right, you can't see that. Let's try this one. It's going to go back to the YZ plane, and that YZ plane is going to be x equals 0. So I have to solve this for x in terms of z. And we're going to go ahead and substitute some of this stuff in. And since she's already started doing it, I guess I'll go that route. Okay, so we have dx, and we have the 1 minus z that I mentioned to you here. And we have the 0 that I mentioned to you here. Up here, actually. So there's that part. Now, if you were to take, and I mentioned that before, let's go back to the beautiful yellow here. We're projecting it back onto this plane, which is the YZ plane, and it's going to come from this equation. So if you graph y plus 2z equals 2, if you have this as your y-axis and this is your z-axis, there's 2 different ways you could solve it. I personally probably would have done something slightly different, but oh well, it's too late now. I probably would have solved it for z, and I would have had ultimately a negative 1/2 y plus a 1. So that's why we have a z-intercept that's a 1. We have a slope that goes down 1 and to the right 2, and that's where this line comes from. Okay, so I would solve it for that. Oops, let's not get rid of all of that. Now, I'm doing dy, or she's doing dy next, and then dz. So that means we're doing a thickness that is going to be, for this representative rectangle, is going to be dz. So the right equation, well, here's why she solved it for y in terms of z. I've got to have it solved for that so that I can put that as my right boundary, and 0 is my left boundary, and this is going to slide from 0 to 1. And there's your setup. And could I do it another way? Of course I could. Oh, here she did it another way. Let me get rid of that stray yellow mark here. So if you change the... Oh, she did it the other way completely. She went ahead and showed the flashlight. Here's her flashlight shining this way. And let me get rid of the yellow stuff. Oops. And she went ahead and shined it back this way. And so the shape that you get is this equation, which is the x plus z equals 1, or you can solve it for z in terms of x, and so you're getting this nice little triangle this way. So you could do it dy, and then because we did the vertical representative rectangle, that's dx, and the high minus low is going to be the dz. So you have your first shape, and that shape is going to be this one, and that's where you solve this for y in terms of z. So it's 2 minus, can't see it anymore, but it's going to be 2 minus 2z for that, right here. And so you've got that back to 0, which is the xz plane. And then it's going to have high minus low, so you have 1 minus x to 0, and it's going to have to slide from 0 to 1. Again, if you were to do this with a dz first, you'd have to have 2 triple integrals. No way, Jose. Alright, so I'll just stay zoomed out for a bit. If you have any questions, you can't ask me questions, what am I saying? If you were to pause it, you could rewrite stuff. If you want me to erase things so you can see stuff better, since I really didn't write any equations, let me just get rid of all this stuff. Now pause it again, and you can see exactly its raw form. Okay, 10:06 on a Friday. Fun, fun, fun. See you later, bye.